Okay, the EM spectrum, the electromagnetic spectrum. Here it is. And the first question is, we have to name the missing part. Well, you've just got to learn your EM spectrum off by heart, okay? So you should know that the missing bit is ultraviolet. Simple as that. Okay. Which part has the shortest wavelength? Again, you've just got to know this off by heart, okay? Radio waves, that's the long end, the long wavelength end of the spectrum, and gamma rays is the short wavelength part of the spectrum. So gamma rays have the shortest wavelength, okay? Radio waves, their wavelength is anything bigger than about a meter, okay? So radio waves, they go up to like thousands of meters wavelength. Gamma rays, their wavelength is about 10 to the minus 12 meters, really, really small. That's a picometer, and that's about roughly the size of the nucleus of an atom. So very small wavelength. Okay. Explain how the frequency of electromagnetic waves in free space differs with increasing wavelength. 2 marks. Okay. So it's asking about the relationship between frequency and wavelength. Okay, so what equation do you know that connects those? Well, it's the wave equation. Okay, so you've got to know this. Wave equation. So for any wave, like a wave on the water, sound wave, you can write down the wave equation, which is velocity is frequency times wavelength. Okay. You've got to know that equation, right? But here we're talking about EM waves, light waves, so they travel at the speed of light. So we don't use V when we're talking about speed of light, we use C. So you can write C is F lambda, okay? It's the same thing. Speed is frequency times wavelength, okay? So it wants to know how the frequency differs with increasing wavelength. So it's asking about how the frequency changes. So we need to rearrange this to make frequency the subject. So divide both sides by lambda and we get frequency is speed of light divided by wavelength. And how does the frequency differ with increasing wavelength? Okay, so it's asking what happens to the frequency when we increase lambda, the wavelength. Well, lambda is on the bottom, so when that gets bigger, the whole thing gets smaller. That's just maths, right? So you'd finish off by saying so as lambda increases, frequency decreases. Okay? And you've definitely got your 2 marks for that. Good. Okay. D. Microwaves are used to heat food. Yes, they are. State another part of the spectrum that is used to heat food. 1 mark. Okay. So, microwaves used to heat food. What do we know about infrared waves? What sort of things emit IR waves? Well, hot things do. Again, you need to know that, right? So, radiators, when they get hot, they emit IR. Hot coals on a fire, they emit IR. So when you're cooking food on a barbecue, for example, the hot coals will be emitting IR radiation or IR waves. So the answer is infrared. They also are used to heat food. Or the heating element in an oven, when that gets hot, that's emitting IR waves as well. Okay, so the answer is IR waves. E. Microwaves are used at airports to detect aeroplanes. A microwave beam is emitted from a large rotating aerial and reflected back off the metal surface of the aeroplane. Explain how microwaves are used to find the distance to the aeroplane. 3 marks. Okay, so we've got this, you must have seen them, right? These big rotating aerial things. Okay, and here's your aeroplane. I wouldn't want to fly in this aeroplane, coming in, okay? So the aerial emits, let's have a change of colour. The aerial emits a microwave, which I'll use green for that, so that'll do. It bounces off the aeroplane and comes back to the aerial and is detected. So it's important to realise the microwave travels twice the distance that the aeroplane is away. Okay. Right, so what was the question again? Explain how microwaves are used to find the distance of the aeroplane. 3 marks. Okay, so first point. The equipment, the aerial, the software, whatever, it records the time taken for the microwave pulse to travel to the aeroplane and come back. So record the time taken for the pulse to travel to the plane and back. Okay. Next, it's asking us to work out the distance. So time, distance, it's a speed equals distance over time question. Okay. So write that down. Speed is distance over time. And it's asking us to work out the distance. So therefore, multiply both sides by t. Distance is speed times time. Now, we're talking about a microwave pulse. It travels at the speed of light. This is all light, okay? So again, you can write speed, use c for speed of light, okay? And then say you would use this equation to work out the distance that the microwave pulse has traveled. Okay, I'm not going to bother writing that, it's too much, but you would have to write that in the exam, okay? So use that equation. And again, I stress that's the distance for the pulse to travel to the plane and back. And the question asked, how far away is the plane? So for all 3 marks, you'd have to say that the plane distance, okay, is half of that distance, okay? So that distance is the pulse distance. Okay, so plane distance equals half times pulse distance. That's it, and you'll definitely get your 3 marks for that. Good. By the way, the speed equals distance over time, the wave equation is the speed equals distance over time equation because frequency, okay, is the number of waves that pass a point per second. Okay, so frequency is the inverse of time. So you can write frequency is 1 over t. Okay. Frequency is the number of waves that pass a point per second, and the time is the time for one oscillation, okay? Or for one wave to pass a point. So if we substitute frequency as 1 over t, well, I'm using little t. You could also write 1 over, in fact, you probably should write 1 over the period. The time for one oscillation, or the time it takes for one wavelength to pass a certain point, okay? So if here's some point in space, time it takes one wavelength to go past that point, that's the period, okay? So the frequency, that's the number of the number of wavelengths that pass a point per second is the inverse of the period. So frequency is 1 over the period, okay? I know this isn't in the question, but it's relevant and you've got to know this, okay? You need to know that equation as well. And look, if we sub that, okay, into this equation, v is f lambda, we get v is equal to 1 over the period, that's f, okay, we're subbing in, times lambda. In other words, v equals lambda over the period. And that's just speed as distance over time, okay? The wave equation, that is just speed equals distance over time equation. It's just that instead of using time, it uses frequency, which is 1 over time. Okay, see, speed of a wave is the distance, that's the wavelength, that's a unit of distance, divided by time, the time it takes for that wavelength, for one wavelength to pass a point. Okay? And that applies to any waves, not just EM waves, okay? Sound waves, waves on the water, whatever. And of course, it does apply to EM waves as well. You would just write C instead of V. Okay, back to the question. So, where are we? So, right, final question. Suggest why it is important for the aerial to rotate through a full circle every 2 seconds. Okay, so that rotates, this aerial goes around once every 2 seconds. Okay, 1 mark. Okay, that's pretty obvious, isn't it? Planes are big, fast and full of people, so this thing has to know where all the planes are, and there's a lot of planes in the airport. It has to get updated where they all are regularly, so every 2 seconds their positions are getting updated, and that's obviously very important for large, fast-moving objects. So something like that, you'll get 1 mark easily, okay? Good. Right. Well, there we go. Learn your EM spectrum. Know it off by heart. Yeah, that's it. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.